Okay, continuing on with our sine and cosine graph exploration here. So what do we know here about our sine curve? Sine curve starts at an intercept up to a max, intercept, min, intercept. Looks like that graph there. Our cosine curve, and again that's all sine curves will have that pattern. Cosine curve starts at a max, heads to the intercept, minimum, intercept, max. Okay, now think of that as one trip, or that length of that trip is called a period. The length of this trip is called a period. Now it doesn't look like it on these two graphs that I just graphed, but we saw earlier that those are for sine and cosine, that is the same, and that distance is 2 pi. Okay, so we're going to call that the original period of the sine and cosine graph is 2 pi. For either graph, there was no restrictions on angles that we could take the sine of or the cosine of, so their domains were both negative infinity to infinity. And their ranges all bounced between -1 and +1. Well, how do these two, well, the range is the height that these will run from top to bottom. They both went from +1 to -1 or -1 up to +1. Okay, that is called actually the amplitude. Okay, so we've got the height of our wave and we got the length of the ride. Okay, how do those two things change? Well, the equation will change them for us. Okay, the amplitude is determined or affected by the a value. So in a equation of y equals a times the sine of bx. There's two variables we're looking at here, a and b, and this would be the same thing for cosine. The a determines the height of that wave. That's called the amplitude. And if a is less than 0 or a negative number, then our graph gets inverted. Okay, now what would an inverted graph look like? Well, for a sine, it would start at the intercept, and instead of going up, it would go down to the minimum, then back to the intercept and up to the max, and then back to the intercept. For a cosine, it would start at the minimum and head up. That would be an inverted cosine graph. Start at a minimum and head up. Okay, and that will happen when this a value is negative, and we'll see an example of those. What would change that period? What would make that, say, for instance, that sine curve, which usually the length of the ride is 2 pi, what would speed it up so that it stops early, or what would slow it down so that it goes farther? Well, that's the b value that's in there. That determines calculate your period. And the way you do this is to calculate the new period of your graph, you take the original period and divide it by that b value. Now for sine and cosine, the original period is both 2 pi. So for sine and cosine, it's always going to be 2 pi divided by b. For tangent, that'll change. Okay, but for today, it's 2 pi over b. And I'll make a note here. Tangent is different. Okay, we'll start to see that tomorrow. Okay, so let's look at some graphs. Okay, we're going to first graph y equals 9 times the cosine of x. Now when we sketch our graphs, we'll kind of do them all the same. We'll start off with this graph labeled like that right there. And we're going to fill in those labels. Okay, it's always 4 tick marks on that x-axis and a max and a min mark on the y-axis. All right, well, first thing we'll always find is our amplitude. Our amplitude comes from that a value. So our amplitude for this graph is 9. Now what does that mean? That means our graph will hit a maximum height of 9 at some point in time and a minimum of -9 at some point in time, and 0 is right in the middle of those. Okay. The period, remember, is 2 pi divided by b. What's our b value here? It's a 1. So our period is 2 pi. All right, so by the time we get to 2 pi, the ride is over. Now, how do we label these landmarks in between? Well, here's the way you do this. You take 2 pi, what's in the middle of 0 and 2 pi? Pi. What's in the middle of 0 and pi? Pi over 2. Then what's in the middle of pi and 2 pi? Well, it's 1 pi and 2 pi. It's 3 pi over 2. Okay, and that's how you can get those labeled. Now, once you do that, once you get that x-axis and that y-axis labeled, then I always say that this is like a window. And inside this window, we have to graph our 5 points. Now we're doing a cosine curve. Now remember, got to remember how how the cosine curve goes. It goes max, intercept, min, intercept, max. Or if you can just remember, it starts at a maximum, goes down to an intercept, have to go down to the minimum, back up to the intercept, finish at the max. Bingo, there's our graph. Okay. All right, so we'll work through this number 2 here, kind of in order. Y equals the sine of 4x. Let's lay out our blank graph here. 1, 2, 3, 4, and then we'll start to fill things in. We can calculate our amplitude. Our amplitude comes from our A value. It's a 1. So that means this graph will go up to a maximum of 1 and down to a minimum of -1 with 0 in the middle. Our period is 2 pi over b. What's our b value is a 4. So it's 2 pi over 4, which is pi over 2. So that means by the time we get to pi over 2, the ride is over. Okay. Now how do I label these other landmarks on this x-axis? I take 1/2 and I divide it in half and I get pi over 4. Or half of pi over 2 is pi over 4. And then what's in the middle of 0 and pi over 2? 1/4. What's in the middle of 0 and a 4th? 1/8. What's in the middle of 1/4 and 1/2? 3 pi over 8. Another shortcut to get this landmark is to take these two and add them together. So that may help you. Okay, let me clean this up. Now, again, we have established that window. That's one period of this graph. And what happens in that inside of there? Well, it's a sine curve, so we need to know how that works. Intercept, max, intercept, min, intercept. Or just remember, for our sine curve, we start at the intercept, we head up to the max, down to the intercept, all the way down to the minimum, finish at our intercept again. And try to make that as smooth as you can. Don't try to draw straight lines in there. But again, we could say, hey, I see a maximum. Where is it? It's at pi over 8. What is the maximum? 1. So the coordinate of that maximum is pi over 8, comma 1. Now again, I'll squeeze this in also our domain. Negative infinity to infinity. We could take the sine of any angle we want. What's the range of this one? Well, just like the basic sine curve, it went from -1 to +1. Okay.